Good afternoon. Thanks for being here and thank you for giving me this opportunity. So I've been under the weather this entire week. I haven't really recovered. So I'm going to restrict myself to this rostrum. Also prevent me from being in front of the slides. And you see a QR code there. That's actually the presentation. You can scan it and download it. And the reason why I put it there was last time I had promised people that I would send the presentation across to them. I thought I did, but I got a couple of calls very recently to say that, sir, you promised and you didn't part with it. So it's up there. And another reason why it's up there is if the fonts are a little small, I mean, you could look it up on your cell phones and follow along. It's I've given a slight tweak to the topic that was given out. Means pretty much the same thing. And security now is, of course, entering a phase where the conversation is no longer about whether artificial intelligence has a role in security. I think the fact that we are sitting here talking about it, that stands answered. And the real question is now more difficult, and it is even more consequential, right? And that question is, how do we design security systems in which machine intelligence can detect at scale and human judgment can still govern the meaningful action at the end of it, right? So that's exactly the question that we're going to explore the next 28 minutes. Because in practice, security does not fail simply because a camera was absent, a rule was missing, a model did not detect enough. More often it fails in the handover. That you are able to detect a lot of issues, but for it to translate into meaningful action, so that's the handover in which it fails. And so this session is not about AI in the abstract. I'm going to talk about things that you and me face on a daily basis. And we're going to talk about how AI can assist. And in case you will invest time, money, effort in looking at AI solutions, which potential partners and vendors will push to us, then we are better informed as to what do we really want out of it. In fact, just a couple of days back, we had a partner coming to us and, of course, talking to us about intelligent video analytics and all. I mean, yeah, that's something that's in the past right now. So what possibly we're going to look at today, when I tell you, talk you through about the entire stack and the architecture, or what constitutes a smart system today, I think at the end of it, we all will come to a common understanding as to what we really require out of people who are creating solutions to us. Right, so let's start with something very, very rudimentary. So it's 1:45 a.m. And in the morning, a loitering alert somewhere in zone B4. On its own, it means extremely, it's insignificant, so it means very little. A few seconds later, there is a bad misuse flag, then a door held open event. But the context in which all this is happening is something that we all are very familiar with, and that is the fourth signal that really appears on dashboard and really spoken about in the right context, and that is alert fatigue. So when you are having these three things that are there, very subtle signals that your SOC has taken note of, but they are all embedded or ensconced in a multitude of other similar signals which the operators have been facing today, yesterday, through the week and the past month. Now, from a purely technical standpoint, this is not a confirmed incident, right? Because there is no visible breach, there is nothing dramatic that has happened, there is no obvious adversary that you can see. And so what we have here is something that we commonly face, and that is an ambiguous cluster of weak signals that do not translate into something meaningful, right? And that is why the decision window that is there on top matters, because the options in front of the operator, there are three options. So if you act too early, you will create disruption, and we face it possibility every now and then when we confront people who are actually legitimate guests. And then there's a lot of song and dance about security being a little high-handed. So there'll be false positives, there'll be unnecessary friction, right? You may confront the wrong person, interrupt operations, like I said, but if you act too late, you risk escalation. right? And there's a classic regret which which confronts all of us, that while the signal was there, we didn't act, right? Because it did not translate into something meaningful, right? So, and that's the reason why I wanted to begin here. Very simple signals that we receive in our SOC on a daily basis, and how this should get translated into something more meaningful using an AI stack. Right. So now security has a new bottleneck. It's no longer, because all our mature enterprises now, we are not short of signals. We have sensors everywhere. We have cameras, we have access control systems, we have IoT devices, we have transaction logs, we have plenty of identity systems, alarm feeds, and everything which is going. So it's detection is no longer an issue at all. So we have signals, we are actually drowning in them. Right. So the organization appears to be very, optimally instrumented, or even over-instrumented, I would say. But it is not necessarily better governed. And we need to understand the difference between them. So we have these signals, but there's not much coming out, but there are still lapses that we face. And because that's where the contradiction begins. So abundance has increased, failure has not disappeared, right? So the problem is that there is a queue overload, because you have so many signals queuing up, and so there's weak prioritization, and there is a weak handoff. So the patterns are not emerging, and we are unable to make sense of it. So that's the new bottleneck that we have, when things are queuing up for us. And but we have to be precise about where the bottleneck actually sits in the entire chain, right? So machine and humans are not failing at the same things. If you see on top, they both do certain things really, really well. They're very strong in their own domains, because machines are very good at scale. What the machines can do, making sense out of that volume of data and trying to emerge patterns out of it, it's seemingly impossible, right? But machines are still weak where security becomes truly operational, and they do not understand context the way humans do. They do not understand ambiguity in the sense of the term that we do, right? So they do not, and they do not carry the cross of failure. They do not carry they don't bear the burden of something that was amiss, because either we overreacted to a signal, or we did not react to a signal. That is something that has to be borne by the humans. So, so it's not a contest really between machine intelligence and human judgment, right? It's a design problem, and that's something that I really would want all of us to agree on and take it back with us. That's everything is a design problem. You may have a great stack which is very capable, but if you cannot leverage it, if it is not designed correctly, if things are not sequential, things are not setting properly, things are not tuned correctly, it's just not going to give you the results. And when I talk about tuning, please don't take your mind back. We have associated tuning with decreasing the sensitivity of the sensors and reducing the number of alarms, then we call that tuning. That's not tuning. Every little signal has to be acknowledged, it has to be made sense of. That's why AI is there to help you with that. So you're not going to reduce the sensitivity and say, okay, now the alerts are manageable, because you're missing a lot. Okay. Okay, so from alert to the case. So alert is something that is being thrown up. How do you make a case out of it, right? And that's the kind of problem that is the heart of the matter, or what I'm talking today. So, like I said, security systems are not failing because we don't have sufficient alerts. They are failing because the organization never successfully converted that alert into something which was a judgment-ready case. We could join the dots, right? And that exactly is the hand-off problem, right? So on the left, you can see what is familiar to every security, motion alert, badge, scan, door open. Separate signals, separate timestamps, and unfortunately often, separate systems, also silos, right? So each one may be technically very valid, and each one may be very visible, but it may be, showing up to a different team on a different system, right? And they're all still wrong. So the first shift that comes about is about correlation, the center patch there, right? And what that means is it's going to bring the related signals together across time, across place, across identity, across sequence. Right? Now we are tuning the system. Now we are doing systems. So the AI, the stack, and we will come into the architecture a little later. What that is doing is bringing together these seemingly unrelated signals across time, place, identity, and sequence, right? So ultimately the system is going to recognize they are not unrelated events. And it's possibly one unfolding situation. But even correlation not the endpoint, because you want to make the system should make a case out of it, right? And that's the real objective for the system. And that's where the handover has to happen. After the case is made, it has to be handed over, right, to the organization to take a call. And the case cannot be just a bundle of alerts, right? It has to be a unified view of what the human can judge. So it should have structure, it should have identity, even if it is something unknown. But at least you're saying whether it's still unknown. It should have a clear timeline, it should have a very clear risk level associated with it, escalation tier, and a very defined response option to what is expected of the human given the circumstances, given the situation that is unfolding. Right. So, in other words, the case is decision ready. So when it is handed off, as an operator, I have everything I need to make a decision. It is not just got a simple alert that is happening. And so it's been made out, so it's a number of signals joined together, a case is made out, and it's presented that these are the possibilities that can happen, and that's when I can take now an informed call. Right, because if the operator is forced to interpret disconnected alerts under pressure, you cannot scale that. You have not run really anything. You just have added more sensors, and the operator is drowning, so it's going to ignore some of it, and perhaps act on some. There will be hits and misses, right? So what a mature system does is it presents cases, not clutter, and it does the heavy lifting for making that case. And that's not where we want the human involvement. Because these are sensors, they're system, they'll be piecing it together, we're going to feed it the logic, on the stack, and they should be able to present the case to us. Right, so this is the reference architecture. Now that we've spoken about the principles, so, and it's simply put there, but this is the reference architecture which I think, works well. And we of course, we agree that the real issue is not detection. We are detecting at scale now. But the conversion of signal into sound action, right? From signal to sound action, that is the obvious question. What kind of architecture is going to support it? To my mind, this does that. Right? So it begins with ingest, which sounds very rudimentary, but it's very, very fundamental and foundational. Right? So you have to have one single, we say that a very mature enterprise will have one single risk window. Similarly, the ingestion has to be something that all sensors throw everything into one pipeline, right? So you're not suffering fragmented inputs. So you correct what you can, and not accumulation for get everything. So you correct what is relevant, and create a common operating picture across cameras, access system, alarms, and any transaction logs, any devices or anything across departments, if you will. And then comes the part called, which is the what makes a capable system do good, and that is the normalization. Often what is happening, and when I interact with even our vendor partners, is that when they do the integrations, what is flowing, the schema is not common. So now when the schema is not common, the system cannot make sense of it. And that's where the misses are. So you'll find that when we talk about intelligent systems, we stop at the detection. Okay, हम ये भी पकड़ लेंगे, वो भी पकड़ लेंगे, वो भी पकड़ लेंगे, detect ही कर सकते. But we are not talking deeper. It is because whatever is being ingested, see, we haven't even reached detection. Detection is the third stage. We haven't reached there. Right now, we've collected everything, we have to put it in the correct common schema for the system to make sense of it. And then we say that, okay, what have we detected? Where is the abnormality? Where is the anomaly that we are saying that it has been detected? Right? Before that, these two steps are there, and which is something that we really have to know, understand, and ask of our partners to say how is it going to work. Right, and so there's detection, and when like I said, probabilities, deviations would be identified. And instinctively, this is, like I said, the part that we most focus on. This is the easiest, most tangible thing that people see or project, and that we satisfy us so that we have an intelligent system that we can detect a lot. And then comes triage. Triage sits in the center because it is that important. Right? That is the heart of it. So you've detected everything, and now triage is where the system will begin to act like an operational partner rather than a signal generator. And so it will prioritize, it will attach significance, it will help distinguish what should be escalated, what is supposed to wait, and what can quickly disappear as routine information. So that's all happening in the triage stage. And from there, the architecture must support decision. Right? So it must support, not replace it. Right? There are too many people keen to automate the decision-making part of it and the action part of it. I think that's, for security, to my mind, at present it's just a no-go. So it should support decision, and which means that that the system should present enough structure and context and consequence to the, like I said, make a case out of it and present it for a suitable decision to be taken. And then comes the response. In some cases, that may mean you could have some automated low-level responses which have low consequence, or they could be semi-automated actions. And one moot point here is that if we intend to automate the response, and if our earlier stages are weak, the response is going to add to the chaos, because the response will not be correct. Right? So if you have really strong earlier stages, you can think of automating something at that end in terms of the response. Otherwise, let that also be something where the humans come in. Right? So, like it says here, I don't think you'll see it, but what it says is for data pumping. What that means is that for every stage, it is not just picking up an event and passing it on from one stage to the other. At every stage, there is value being added. Somewhere there's a context being added, somewhere there's a pattern emerging, somewhere it's getting linked to something else. So every stage, there's some value being added. And it's not just the event being handed over till it lands into you just as a signal spike to say that this has happened and you're supposed to know what to do with that. Right? And so when we talk about human in the loop, we are not talking about one approval box near the end of the chain. We are talking about a system whose layers have been designed so that the time the human judgment is required, it is being applied in a meaningful, informed fashion. Right? And these are the three things that usually work. One is, of course, human in the loop, which is a strong control. So human is placed deliberately at the point of decision. And then you have human on the loop, which implies a weaker arrangement that is just broadly supervising, and it's more or less functioning on its own. And then of course you have the human out of the loop, which is a fully automated system, and very, very difficult because of the consequences associated with security and safety incidents. Right. Okay, this is an so we dealt with, I spoke of very, very basic case about, about some signals. Now this is where it becomes interesting and a little complex, right? So, and many of the harder problems in security do not announce themselves in very, very readable signals, which look like anomalies. They could be very, very subtle, normal things that are happening, but we have to have systems that can even make sense of that. Right, because these things, particularly inside of threat, they unfold very slowly. We have somebody who knows the system and is trying to, beat the system. So here we are looking at a multi-day pattern. On the first day, what appears as a transactional anomaly, small repeated transactions, not large enough to cause immediate alarm. On the second day, the pattern begins to deepen. There is recurrence near sensitive assets and movement that is not yet improper, but no longer can feel incidental. Then on the third day, the situation becomes more difficult to ignore. So you have off-duty hours, signals emerging, repeated access at unusual times, and so on. And what is still absent, however, is that there is no single high-severity alert so far. There is no dramatic breach that has occurred. And not even that will compel intervention by an operator or by a security professional. And that is why such cases are often mishandled. Because we are only looking at alarms and we are only looking at to act on alarms. We do not have an engine that is piecing together even rudimentary actions and questioning as to why it happened. Okay, and that's the beauty of insider threat is that unless you have a system that can make sense of even logical legal actions and emerge the anomaly out of those, insider threat is difficult to catch. And that's why when we, even now when we catch things have been going on for 6 years, 8 years, we come to know because of some slip up. You wouldn't have known now, right? So if you see the need box on the right, and it's an important one. It talks about correlating the weak signals into a reviewable case, and that's what we spoke of earlier. And even the context slide that you see there, it says that everything is normal, but the case is now being made out that there is an insider threat, right? Okay, silo failure, I think I spoke about it in passing, and so operations will see manual deviations and weak operational irregularities, but possibly they may not share data with the security in real time. Finance will see transaction failures, will see transaction and low level trickling transaction anomalies, but often they will review it with their own logic. And so, like what I'm saying is, separate silos, separate signals, and no way of piecing it all together because there's no data flow happening. Because the ingestion layer, which is the first layer, what I was talking about, is disparate. And since there is no ingestion and there is no normalization, there is no common schema in which the things are being absorbed, we really can't make sense. And so the detection layer starts failing. Right, so once a system becomes better at detection, correlation and triage, a new risk emerges. And that is, and the risk is not only that you may miss something, the risk is that you act too quickly or too broadly, or or with too little context, and that is where control logic matters. So at the first year, low impact actions can and should be automated. Informational notifications, camera retasking, additional logging, anything that you want to do which is automated, you should automate all of that to take the amount of effort and work required by an operator or its shoulders. Because the downside of these actions are limited and reversible. In the second tier, once the consequence becomes material, human approval must become mandatory, right? So in case you want to revoke an excess or there's zone lockdown to be done, or HR or legal notification is required, it should happen with human intervention, should be an automated feature, or email shooting off without human intervention, right? And then of course there's a third tier, which is the mandatory control, right? And that is for irreversible actions. So in case you decide that this is the escalation layer, this is an irreversible action, 100% mandatory human controls should be there. Right? And so when I actually talk about human in the loop, this is one of the most important meanings of the phrase. Not simply that the human is somewhere embedded in the chain, but that the architecture has been so designed that the human control tightens as the consequence of action arises. Alright, so that's the distinction we got to make. Not automate everything, but we have to have things that can, may, but must not be automated, right? Okay, headed to the end, last two slides, and so just to sum up, a few truths out there. Firstly, of course, confidence is not truth. What that means is that system may assign a high confidence score to a pattern, an anomaly, or a recommendation, which is very, very useful. I mean, that's how you design systems. But that's not the same as reality, right? Confidence is an expression of belief in a particular AI model, that it works the way it's supposed to work, right? And truth is what the organization will eventually have to live with, with all the actions that they took based on what was served to them, right? So they're not the same thing. Then of course anomaly is not intent. So while the system does throw up an anomaly to you, it does not necessarily mean that the intent may be fraudulent. And that's the reason why you have to have that human make sense of it, right? And detection, of course, is not authority. So even if a system has detected, correlated an act and even recommended a particular action, none of that by itself creates authority for the operator or for the security professional to take a particular action without putting his mind to it. Right? So the human in the loop is that important, right? That's exactly the nature of the talk that we had beyond algorithms. How do humans and machines balance out? So let me close this with a short test for executives as to how would you Of course, we discussed architecture, triage, correlation, control logics, and human in the loop. The real question is very simple. How do you know whether a system is actually mature? Right? How do we have standard and understanding? So basic questions to ask. First, what was detected? Not in vague terms, not as a generic alert label, but specifically what has been detected, what signal, what anomaly, what event sequence, what pattern emerged. Right? So that's the question that is to be asked as to what has been detected. Second is, why was it prioritized the way it has been prioritized? So you are questioning the triage to say, has it been prioritized correctly? If the system cannot explain why this case was given a particular ranking, I mean, you could have set some rules there. So you have to question the rule to say as to why this was applied to it. And and if the system can explain that, brilliant. Third is what context matters. And this is, I think, one of the more important questions to be asked of the entire system is what background, because now we are talking about historical data, what background, what history, what environmental, behavioral context. That is something that is most missed out, and that is something that AIs can actually lead for us, is the behavioral context of humans involved in there. And so because without context, the organization is actually not really deciding, it is only reacting to what has been served. Right? And fourth is who decided, not who was notified and who actually held authority, accountability, and approval responsibility. So mature system should not blur that. And fifth is, of course, what action was taken, and that action has to be audited. So at the end of it, if some incident or signal is thrown up and you've taken a particular action, the system must enable you to construct the entire life history of that incident backwards to say what exactly happened. And why that is important is because the last stage, in case you missed that, was learning. Right? Because systems will not learn if you do not go back and see what did you do it well. And that is my ground with many partners also who come to us and say that we have an AI system, and we ask them, okay, the AI is never at our end, at the user end. AI is always at his end. So he's used AI to make the system, but when he serves it to us, it's like any other system. He'll have to go back and retrain it, but does not get trained while it's in mathematics. Right? Right. So for me, the standard is not whether the system can, generate alerts, and I'm just closing up here, not whether the dashboard looks pretty advanced, but whether at the decisive moment, and that's the question that's there. At the decisive moment, the architecture produced judgment or an informed case for the human to take the right call at the right time. And that's probably the architecture we require in the AI first world. Thank you. Yeah, in case you missed it, you ask one back.